Hello, this is Professor Gibson. This is a video about Chapter 8, Section 4 for Intro to Stats, Math 201 and Business 230. So what's happening here, again, it's a comparison of two things, hypothesis test about a comparison of two things, but this time it's two proportions, all right? So the two things that are going to be different from most of the stuff we've done before, the fact that it's two proportions is going to change here a little bit. It really works the same, but they'll look different, okay, in the way the hypothesis tests are written. And then it's also going to have a much different looking test statistic. Okay, in fact, the test statistic is messy enough that, like with 8.1, I'm going to show you a different way to do it on the calculator. I will also show you how to do it in Excel. All right, so let's start our first example here. A survey was conducted of newlyweds in a country who have a spouse of a different race or ethnicity from their own. The survey included random samples of 1,000 newlyweds in ethnicity A and 1,000 newlyweds in ethnicity B. All right. In the survey, 14% of respondents in ethnicity A and 25% of respondents in ethnicity B had a spouse of different race or ethnicity from their own. So I've written this stuff out down here. So what's happened is there's 1,000 of both the surveys. So the N1 is 1,000 and N2 is 1,000. The proportions are 14% and 25%, so that's 0.14 and 0.25. No, these are the p-hats, right? Because these are from the data. They're the hat. The ones with the hat, they're the samples. Okay. At alpha equals 0.01, okay, so here's our other number. Level of significance of 0.01. Is there evidence to support the claim that the proportion of newlyweds in ethnicity A who have a spouse of a different race or ethnicity from their own is less than the proportion in B? All right. So another thing that we're going to need to, so over here, right, this right here, I've just copied down the numbers out of that. Okay. So another thing that we're going to need, I went ahead and calculated right up in the beginning, is we're going to need the x's, right? What happens is a proportion, the proportions are the p-hats, is the x 1, say, over the n1, the number of positives over the total number. Okay. What happens when we enter it in the calculator, we're going to need the x's. And even if we do it in Excel, either way, we're going to need the x's to do the test statistic. So if you solve this for x, well, that should have been 1, right? Multiply both sides by n1, you get x, right? So this is what it would be for x1, and then for x2, it'd be p2, n2, right? So here I got x1, 0.14 times 1,000 is 140. x2, 0.25 times 1,000 is 250. All right. Now, let's go back to the claim. Is there evidence to support the claim that the proportion of newlyweds in ethnicity A, yada, 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 is less than the proportion in ethnicity B? So the claim is that P1 is less than P2, where A is ethnicity 1 and B is P2, right? This is the claim. There's no equality there, right? So that means this is the alternative. So the null then will have the complement of less than, which is greater than or equal to. All right. And you'll see right here, that's what we have there. All right. Now, the next question is to calculate this down here, calculate the standardized test statistic. So, very similar to what we did last time. Let's do it on the calculator first, and then we'll talk about all these calculations in hand here for the Excel. I'm going to go stats, hit right arrow twice, pick tests. Then we're going to pick, this time what we want is to prop, which prop is short for proportion, z-test. All right, and then after that, we'll just enter the stuff that they ask us for. So on here, let's grab the calculator. All right, so there's the calculator. It's on, so stat, Right arrow twice to test. Come down to 2 prop, z-test. You see it's number 6 there. Hit enter. All right, now you'll notice it asks for x1, n1, x2, n2. It doesn't ask us for the p's, it asks for the x's. It'll calculate the p's itself. So our x1 is 140. Our n1 is 1,000. X or n1 and n2 are the same this time, but they don't have to be. Sometimes they are, sometimes they're not. Okay, so this is the tail of the test, P1. Oh yeah, we didn't really talk about that one yet. So the tail, if you look at it over here, the tail is driven off of the alternative, right? So the alternative right there is a less than. So this is a left-tailed, right? We're in the left-tailed option here. We're going to end up doing the p-value, but we're in left-tailed. Okay, so we need that to do the into the calculator. So we pick arrow over right to pick the less than. Hit enter to set it. Arrow down a couple more times. Now, calculates highlighted, pick highlight. Now, so what we have here, first we have our test statistic, minus 6.208. You'll notice, by the way, that this matches what I got from the calculation when I did it for what we would do in Excel. And they've just rounded to 2 decimal places here, minus 621. We also have P. Now, P this time, if you look at this thing, this is times 10 to the negative, right? Times e to the times 10 to the negative 10. That's because look at our test statistic. It's way out there at 6, well, negative 6. So that's why this p-value is essentially 0. Really, it's 9 zeros and then a 2, right? But so it's basically 0. Okay. Now, if you were going to do this in Excel, okay, right here are the formulas, and you have to work them out. Okay, it took me about 3 minutes to do this myself, just to get it all written out and then type it in Excel. First, what you do, see this is the main formula here, but see it's got P bar and Q bar. So first calculate P bar, all right, and it's x1 plus x2, that's these numbers here, right? X1, 140, x2, 250, over n1 plus n2. Work that out, it's exactly 0.195. Then Q bar is 1 minus that, so that's 0.805. Now we're ready to plug the rest in. P1 hat is 0.14 minus P2 hat is 0.25 divided by C. We're just plugging into this formula right here. Square root. Remember when you do multiplication in Excel, you have to put a multiplication symbol in between. All right, plug it all in. Comes out minus 6.208, which is exactly what the calculator gave us, and it rounds to minus 6.21. Okay, keep moving on here. All right, so the p-value is 0, right? If you remember our alpha this time, it was 0.01. So what we have here is p is less than alpha, which means we're going to reject, right? Remember, alpha was the lowest probability we're willing to accept, and we got a probability of, you know, 0.0009 times, right, out to a 2. So we're going to reject HO, right? No, so now we'll get to conclusion. Since P is less than alpha, right, we reject the null. There, and then got to go remember and see what the claim was. If you remember, the claim was the alternative. Since we've rejected the null, that means the evidence supports the claim. Well, it supports the alternative, which is the claim, right? So this time we're going to support the claim. There is evidence to support the claim that the proportion of newlyweds in ethnicity A who have a spouse of different race or ethnicity from their own is less than the proportion in ethnicity B. Okay, so that is it for that one. All right, in a 4-week study about the effectiveness of using magnetic insoles to treat planar heel pain, 58 subjects wore magnetic insoles, 44 subjects wore non-magnetic insoles. The results are shown to the right. Okay. At alpha equals 0.09, can you support the claim that there is a difference. Okay. So this is the first one of these we've done where we were talking about it. They have others in the homework. Is a difference. Well, is a difference means not equal to. Okay. In other words, this time what it is that P1 is not equal to P2. That obviously does not include equality. That's our alternative, right? And there's the claim. And then the null then will be the complement of that, where P1 proportion 1 equals proportion 2. Okay, alpha is going to be, pick kind of unusual alpha this time, 0.09. By the way, in the real world, whenever you see an unusual alpha, you should be just a little bit suspicious that somebody's manipulating their results. All right. So we come down here. Identify the claim and state it. So they just have this thing where we state it in words. Restate in words what they said up above. The claim is the proportion of subjects who feel better with magnetic soles is different than those who feel better with, and it cuts off here, but it says non-magnetic soles. All right. So then the question now is what are the hypotheses? And it's equals and not equals. So that's this one here. Okay. Now you'll note I wrote all this stuff down here. And this time they didn't give us the proportions. I don't know if you did notice, but they didn't. Instead, they give us the numbers. They give us N1 and N2, and they give us X1 and X2. So what they give us is these here, N1, N2, and then up here are the X's. See the yes, that is X1, 21, and the yes here, X2, 16. All right. So what I'm doing here, P hat 1, for example, is X1 divided by N1, right? There were 21 yeses out of 58 total subjects in that one. And then P hat 2, there were 16 yeses out of 48 total subjects. Do the division. These are very close to each other. You see that? I'm guessing that this is not I'm guessing we're going to support the null here. Those are pretty close. I don't think they're going to end up being different, but let's see how the numbers play out. So this one is a rejection region question, right? Our alternative hypothesis is not equal to, so it's two-tailed, rejection region two-tailed, right? So our rejection region is going to be plus and minus I and V norm, put in the alpha, 0 and 1. So what we get out of that, we're plus and minus, so we're going to have negative 1.70 on the low side and positive 1.70 on the high side. All right. Here's our two-tailed thing, negative 1.7 and positive 1.7. Okay, we're running out of time, so I'm not going to kick it back into the calculator. All right, when you go in, you'll see it'll remind you. Remember, it's going to ask for the X1 and the X2, all right, which they gave us this time at 21 and 16, and then the N1 and the N2, 58 and 44. All right, you can type those numbers into Excel as well. Get minus 0.0156. That's exactly the same thing that the two-prop Z will give you, right? Two-prop Z test. So at that point, then we have found this will give us a standardized test statistic is minus 0.02. The rejection region is minus 1.7 and below, right? So this minus 0.02 is between these two, right? So it's not in the rejection region. We are going to fail to reject. And it looks like we're going to fail to reject. And then the claim matched the alternative, right? So that means there's not enough evidence to support the claim. All right, that's it for this one. I hope you found that helpful.